Lesson 7.6 Exponential Functions to evaluate and graph exponential functions. An exponential function is a function that repeatedly multiplies an initial amount by the same positive number. You can model all exponential functions using y equals a times b to the x power, where a is a non-zero constant, b is greater than 0, and b does not equal 1. An example would be y equals 100 times the quantity 2 to the x power. These are two graphs of exponential functions. This one's a decreasing function and this one is increasing. Suppose all the x values in a table have a common difference. If all the y values have a common difference, then the table represents a linear function. If all the y values have a common ratio, then the table represents an exponential function. Problem 1. Does a table or rule represent a linear or exponential function? Explain. Well, first you need to figure out the difference between each of the x values. The difference is plus 1. Then you need to find the ratio between each y value. Clearly this is not going to have a common difference, so we have to look for a ratio, and the ratio is multiplied by 3. Since the x values have a common difference and the y values have a common ratio, this table represents an exponential function. If we look at the equation y equals 3x, the rule represents a linear equation because it is in the form of y equals mx plus b. Also, the independent variable x is not an exponent. Problem 2. Suppose 30 flower beetles are left undisturbed in a warehouse bin. The beetle population doubles each week. The function f of x equals 30 times 2 to the x power gives the population after x weeks. How many beetles will there be after 56 days? Well, since x represents the number of weeks, and we're given 56 days, we need to convert the days into weeks. Divide that by 7, we have 8 weeks. So we're going to plug that number in into our function, and we get 30 times 2 to the 8th power, which is 256 times 30, and that becomes 7,680 beetles after 56 days. What is the graph of y equals 3 times 2 to the x power? First, you need to make a table of x and y values. So pick negative or positive numbers, plug those numbers into the function, and then figure out your y values and create a list of your coordinates. Once you do that, you plot the points on a coordinate plane and connect the points with a smooth curve. So our first point is negative 2, 3/4. We have negative 1, 3 over 2, which is 1.5. We have 0, 3, and 1, 6. Notice that these points do not create a straight line, and if we were to connect it with a smooth curve, it would look something like this. Does this table or rule represent a linear or exponential function? Explain. Well, first we need to look at the x values. We have a common difference of plus 1. If we look at the y values, we can tell that to go from negative 1 to 1 and 1 to 3 and 3 to 5, it's really increasing by 2, so that's a common difference, so this one is a linear function. This equation here, however, is an exponential function because it's in the form of y equals a times b to the x power. Here's another problem. An initial population of 20 rabbits triples every half year. The function f of x equals 20 times 3 to the x power gives the population after x half periods. How many rabbits will there be after 3 years? Here we have to realize that x represents half year periods, and they give us information about, they want us to find information about 3 years. So we need to convert that 3 years into half years, which would be 6. So we are going to solve our function f of x when x equals 6. And we're going to do 20 times 3 to the 6th power. 3 to the 6th power is 729. So we're going to do 20 times 729. And that gives us 14,580 rabbits after 3 years. What is the graph of y equals 0.5 times 3 to the x power? First, you need to make a table. We're going to pick negative and positive points. So let's do -2, -1, 0, 1, and 2. If we plug in -2, that would be 1 over 9 times 1/2, which would be 1 over 18. -1 would be 1/3 times 1/2 is 1/6. 0 would give me 3 to the 0 power is 1, so that would just be 1/2. And 3 to the first power is just 3 times 1/2 would be 1.5 or 1.5. 2 would be 9 times half, which would be 4.5. So just because my graph is a little small, I am just going to plot the points from 0 on up, because the points in the negatives are going to be very, very close to the x-axis. And notice how from this point to this point it only goes up a little and then it increases a lot. So if I were to draw a nice smooth curve, it would look like this.